So, students, it has been observed in our daily life that the things released from a certain height fall down on earth, and Newton's first law of motion does not allow any change in the state of motion of a body unless there is net external force acting on it. So, it means the things falling towards the earth must be due to some force. It is said that a falling apple sparked the idea in the mind of Newton that earth attract all the objects towards its center. And Newton generalized this idea and said that every object in the universe attract every other object with a certain force. And he used Kepler's law to explain or deduce this law. So your next chapter is chapter 10, which is about gravitation. In this chapter, we'll discuss about the law of gravitation, what is gravity, what is gravitation, what is the difference between the gravity and gravitation, Kepler's law. Although these laws are not in your syllabus, but we'll discuss these law in order to understand the concept of Newton's law of gravitation. After this, we'll discuss about the gravity, acceleration due to gravity, its value on Earth and Moon, and so many other topics. So the main contents are the gravitation, Kepler's laws, universal law of gravitation, force of gravitation on Earth and on Moon, acceleration due to gravity on Earth, on Moon, equator and pole, free fall, and the difference between the mass and weight. Now, what is this gravitation? So, gravitation is something whenever an object is moving towards the center of gravity. It is said that it is under the influence of gravitation. So, all the objects falling towards the center of Earth, towards the surface of Earth, that effect is known as gravitation. So, what is this gravitational force? Basically, the gravitational force is the force with which two objects attract each other due to their masses. That is gravitation force. This force exists in every part of universe, and the force of gravitation exerted by earth on the bodies is called gravity. So this is the basic difference between the gravitation and gravity. Gravitation is the force of attraction between the object that exist in this universe, and on the other hand, the gravity is the force exerted by the objects in on the earth. Now we can see there is a beautiful animation in which all the planets are revolving around the sun and the satellites are revolving around the planets. Now these revolutions of the planet or the satellite is because of the gravitation pull of the sun on planets or of planets on their respective satellite, and this is happening because of this law of gravitation which was given by the Newton. Okay, so Newton used basically the Kepler's law to explain these concept of this gravitation. So in our next topic we are going to discuss about the Kepler's laws of motion. So basically Johannes Kepler gave three laws to explain the motion of planets around the sun. So these are the three laws. Number 1, the law of orbit. According to this, each planet revolves around the sun in elliptical orbit with sun at one of the two foci of the orbit. So look at this picture. Sun is present at a position and the planet is revolving around the sun in an elliptical orbit. Now for an ellipse, we are having two foci, and the foci is the plural of focus. So sometimes the sun is at one position, sometimes the sun is at another position, and the planets revolve around the sun in an elliptical orbit. Second law is law of areas. According to this law, The line joining the sun and the planet sweeps out equal area in equal interval of time. So let us consider a planet which is revolving around the sun from position A to position B in time t, then from position x to y in the same time interval t. So the area swept by the planet for this position A to B and x to y is same for the same time interval. So then according to Kepler's law, second law, this area SAB is equals to SXY. Next is our, so in this we discuss about this law of area. Now, so the from what we are concluding from this, the velocity of the planet revolving around the sun is not uniform, but changes, and in such a way it changes that the planet sweeps out equal area in an equal interval of time. So, what we are concluding here, the aerial velocity of the planet around the sun always remains constant. Next law is law of period. According to this, the square of time taken by the planet of revolution around the sun is directly proportional to the cube of mean distance from the sun, or we can say the cube of semi-major axis of the elliptical orbit. That is, t square is equal to r cube. So this is, t square is proportional to r cube, or we can say t square is equals to constant into r cube, or t square upon r cube is a constant. So from this figure we can conclude, or we can see that the planet is revolving around the sun. V is the aerial velocity of the planet, r is the semi-major axis. So the time period of revolution taken by the planet around the sun is, that square of that is equals to or proportional to the r cube. This is a beautiful picture to explain the law of gravitation. All the planets are revolving around the sun in elliptical orbit, and here the apple is falling towards the center of earth or the surface of earth because of this gravitation law. So this Newton law of gravitation, or gravitation, exists everywhere in nature. So Newton used this law to explain this basic gravitational force. So that is known as Newton's law of gravitation, and Newton explained this third law of this Kepler to explain or deduce the Newton's law of gravitation. According to that, each particle of the matter attract every other particle with a force which is directly proportional to the product of masses and inversely proportional to the square of distance between them. So according to this law, the force of attraction between the particle is, number 1, directly proportional to the product of their masses. Number 2, inversely proportional to the square of distance between these particles or objects. So let us consider two objects. One is object A, another one is object B, with masses m1 and m2, and both are exerting force on each other. F1 is a force on m2 and f2 is a force exerted on m1 because of these two objects. And this r is a separation between these two objects. Now this F1 is equals to F2. This is in accordance with the Newton's third law of motion, that is, for every action there is equal and opposite reaction. Now combining this with Newton's law of gravitation, that is, force is proportional to the product of masses and inversely proportional to the square of distance between the objects. Combining these, we are getting that F is equals to F1 is equals to F2 and is equals to G m1 m2 upon r square, where G is the universal gravitational constant that remains constant throughout the universe. So what we are having here, that the force of gravitation is proportional to the product of masses, that is, F is proportional to m1 m2, F is proportional to 1 upon r square, and let us combine these two, and what we are getting, that this force acting between the two objects is proportional to m1 m2 upon r square. And let us removing this constant of proportionality, that proportionality sign with the constant of proportionality, and our required formula is F is equals to g m1 m2 upon r square, where g is constant, that is known as universal gravitational constant, and the value for g is 6.67 into 10 raised to power minus 11 newton meter square per kg square, and this g is constant throughout the universe. Now our next topic is acceleration due to gravity. Now, according to this acceleration due to gravity, the acceleration of with which the object is falling towards the earth's surface, that is known as acceleration due to gravity. And in this figure we can consider here that we are having earth, apple is falling towards earth, m is the mass of earth, small m is the mass of apple, and Fg is the force with which the earth is attracting this apple towards its surface. Applying Newton's second equation and Newton's law of gravitation and combining these, we are getting that acceleration with which the object is falling towards the earth is equals to gm upon r square, and that is equals to g, that is known as acceleration due to gravity. Hence, acceleration due to gravity g is directly proportional to the mass of earth and inversely proportional to the square of the radius of the earth. Now, after discussing this acceleration due to gravity, let us discuss about the difference between gravitational constant and acceleration due to gravity. This gravitation constant is known as universal gravitational constant. Small g is known as acceleration due to gravity. The value for gravitation constant is 6.67 into 10 raised to power minus 11 Newton meter square per kg square, and therefore acceleration due to gravity is 9.8 meter per second square. This g remains constant throughout the universe, but the value of g varies from place to place in this universe. The value of this gravitational constant is 6.67 into 10 raised to power minus 11 Newton meter square per kg square on moon, but on earth the value of this g falls to 1 by 6th of the value on the surface of earth, that is g vary from place to place. Now our next topic is free fall. What is free fall? Whenever the object is falling just under the effect of gravity only, that is with the acceleration equal to the acceleration due to gravity, in that case the object are said to be free fall. And let us consider a figure. Here we are having the skydivers and they are falling freely. This is the free fall example. They are falling freely under the effect of gravity only. No other force is acting on these divers. So this is example of the free fall, that the object are falling freely under the effect of gravity only. So whenever we are when we make a feather and the coin to fall in vacuum, they will fall or reach the bottom at the same time, that is under the effect of gravity they are falling, and no air resistance, nothing is acting on this. So this free fall is free from the dependence of the force of gravity or the mass of the objects. Our next topic is mass and weight. What is mass? Mass of object is defined as the quantity of matter contained in the body. Now, the mass is measure of inertia of the body. So, mass is also known as inertia mass and its unit is kilogram. So, in layman language, we used to say that the mass of object is 5 kg or the weight of object is 5 kg. But there is a lot difference between that mass and weight. Now, what is weight? The force with which the object is attracted by the earth, that is known as weight. The weight always act vertically downward direction towards the center of earth, And the SI unit for measuring the weight is Newton or the kg weight. The formula for weight, as the weight is force, and so weight is equals to F is equals to m into A is equals to m into g, where m is the mass and g is the acceleration due to gravity. So let us discuss about the difference between the mass and weight of the objects. Mass of a body remains constant, weight of a body changes from place to place. On a mountain, we are weighing with a different value as that on ground. Mass of a body can never be zero, but weight of an object can be zero. Where the acceleration due to gravity is zero, the weight will become zero, like at the center of Earth. Mass is scalar quantity. Weight is a vector quantity. Mass is measured in kg, weight is measured in Newton. Mass can be measured using beam balance, wherever the weight is measured using the spring balance or the weighing machine. In this chapter, we are going to calculate some relations or the values for the mass of sun, the force of attraction between the sun and earth, and all these. So for that we need to remember some values, that is the radius of earth, that is equals to 6.4 into 10 raised to power 6 meter. Mass of earth is 5.98, that is nearly equals to 6 into 10 raised to power 24 kg. Acceleration gravity is 9.8 meter per second square, and the value of acceleration on moon is 1 by 6 the value of the acceleration due to gravity on earth. So these are the topics we are going to discuss in detail in this chapter.